All right, friends, it's your boy, Mr. Shading, coming at you with Unit 3, Lesson 1, What are scaled copies? Practice problem. So this homework comes from Lesson 1 of what we looked at today, which is looking at scaled copies. So in the first question, it says, here's a figure that looks like the letter A, along with several other figures. Which figures are scaled copies of the original A? Explain how you know. So in class we talked about images, and we talked about distorted images or slanted images are not scaled copies. So what I want you to do is I want you to first go through and say, this one looks slanted. So that is not a scaled copy, not scaled copy. So we can already write on that. We also determined that a scaled copy would have side links that are multiplied by the same thing. So what I'm going to do is I'm going to outline this A in sort of a rectangle, and I can do that. So this is a 2 by 2 by 2 by 2, and that's not really a rectangle, but that's a square because all the sides are the same. So it's a special type of rectangle, a square. And so those are all 2, so then I'm going to do the same thing to figure 2. This one is 1, 2, 3, 4. Each side is 4. And so we can see that this is twice the size of that, and it's 4. So figure 2 is double the original, which makes it a scaled copy. So scaled copy. And then figure 1, if we look at figure 1, we box this, that makes a rectangle and not necessarily a square because this is a 2 by 3, so not a scaled copy, not a scaled copy. And then we already determined figure thing is, that's wrong. So this one is in a square, and it's 1 by 1 by 1 by 1, which is half of the original figure. So figure 4 is half the original. So it's a scaled copy. And that's one way that we can determine is by looking at the side links and examining those. So figure 2 and figure 4 are scaled copies of the original figure. And that's, we know because we determined this was a square, these are also squares, this is double the size of a square, this is half of the original square, or the A, and so we, we determine that way. This one, still going with scaled copy. Tyler says that figure B is a scaled copy of figure A because all the peaks are half as tall. Well, remember that a scaled copy, if you do half of the peaks, that means that half of the, so he's saying that the height did decrease by half, right? So he's saying that the height, but I'm wondering, this distance looks about the same on both. So it did not decrease by half in the width, so therefore, Tyler is wrong because a scaled copy must be, it's wrong because a scaled copy must be scaled the same on all sides. So in this example, right, it did cut down the height, but the width stayed the same. And so what we're trying to understand is that a scaled copy has, so if this is half, the width has to be half as well, and the width is still the same. So that's why we're disagreeing. So Tyler is wrong in his understanding of that. Moving on to the next page, it says here is a picture of the Rose Bowl Stadium in Pasadena, California. Here are some copies of the picture. Select all pictures that are scaled copies. Well, remember, we looked at images before. This was from our first activity today. We looked at images, and we know that if an image is stretched, right, it's not a scaled copy. B is stretched. We also talked about that, that's distorted, right? So this is not a scaled copy. C is also stretched. And so that's not a scaled copy. A and D look like the same image, and it just looks like it's scaled properly. So for this example, these two are same picture, different size. Same picture, different size. This comes from activity, the first activity we have, so this is from 1.1, so if you want to refer to that in your notes to help you understand how we got those answers, you can. And then down here it says complete each equation with a number that makes it true. This part is talking about scaling, because scaling is multiplying a number. So some number times 5 equals 15. Well, to solve for this, I'm going to divide both sides by 15. 15 divided by 5 equals 3. And we know that 5 times 3 equals 15. This one here, divide both sides by 4. And then I have 32 divided by 4 equals 8. So I know 8 goes there. Same thing here, I'm going to divide both sides by 6. Of 9 divided by 6, or I can write that as a fraction, 9 over 6. I'm going to simplify. Divide by 3, divide by 3. This is 3 over 2, or 3 halves, so I can write that here, times 3 halves, or times 1 1/2, right, if that's what you want to do. And then I'm going to divide by 3, or divide by 12 here, and divide by 12 here. 3 over 12, simplify. 3 divided by 3 is 1, 12 divided by 3 is 4. This is times a fourth. So I'm just showing you that to get these answers, you're going to divide your end result by the factor there in order to get that answer. This comes from something that we started last unit, but this is also tied into scaling, because every time we look at scaling, we're looking at what is multiplied by each side in order to get another side length, and that's leading us there. This first activity that we did today, so if you wanted to make sure, this first activity comes from, I want to say it's 1 2/10, which is the little letter F. And then this activity here, where we're looking at this, this one will probably be connected to 1 3/10, so the same image, but is it scaled properly on all sides? So that way you get an idea of where these come from. So that's the end of today's lesson, and I look forward to seeing you all tomorrow.